class we were completing, we have completed till the focal length. Yes, what was the relation of focal
Yes,
length
ma'am.
and the radius?
Focal length is half of radius.
Half of radius. And there was a small derivation also, which we did.
Yes, ma'am.
So all the cases we have seen, all the 4 rules. Your assignments are pending.
Yes, ma'am. I'll submit it today. I forgot about it. I'll submit it today.
Okay, so tomorrow we can discuss them, है ना?
Yes, ma'am.
EMI we have already discussed. AC few are left, no? And EM waves is complete. AC 3 assignments are left or 4? I think 4 are left, no?
4.
4. No. So see, that was the relation between the focal length and the radius, and this derivation can come in the exam. Now, the mirror formula. Mirror formula, you've already studied it in your earlier classes as well, but you never studied its derivation. So we'll be seeing its derivation. Let's say we have an object in front of the mirror at some distance. Now, what will happen? The rays of light, the first ray will be parallel to the principal axis and it will pass through the focus. Okay, the ray of light
Yes,
will
ma'am.
be parallel and it passes through the focus. The first rule which we have studied, are you able to recall it?
Yes, ma'am.
Second ray passes through the center of curvature and it retraces its path, the second rule. And because it's a derivation, we are not seeing where are we exactly getting our image. We are not seeing, this is a derivation. So for derivation, we might need few more things, correct? So for that
Yes, ma'am.
purpose, see, we are seeing this, we are taking the third rule also, that when the light ray strikes the pole of the mirror, it passes through, means it will have the angle of incidence equal to the angle of reflection passing through, like this. So wherever all the intersections will be formed, that will give us our image. But right now, the purpose of this one is to just make more things for the derivation. Okay. Sometimes in the derivation,
Okay,
we are
ma'am.
allowed to do geometrical construction. So similar to this is also, see, by using the focal one and the center of curvature one, you can directly get your image, right? You can directly get your image in that case. But here,
Yes, ma'am.
the object passes through the pole of the mirror and it gets reflected, it gives you more triangles. Like this is one triangle and this is another triangle. So that we can use the similarity property of triangle. Remember the similarities of triangle. Two triangles are said to be
Yes,
similar.
ma'am.
So here what we see, this is AB, this is A dash, B dash, this is angle of incidence, angle of angle of reflection. This is the focus, this is the center of curvature, and this is the pole of the mirror. Now, these things we'll discuss later. First, triangle A, B, and C. See this one. A, just mark it. See this triangle A, B, C, this triangle. Okay. And if you see the smaller one, A dash, B dash, C dash. Now we'll have to compare them through any property if we are able to compare them. Look, vertically opposite angles and the same
Yes, ma'am.
side. This one is the same side, right? The base one. So both the triangles are similar. Okay, they are not equal, they're similar. I hope you know the difference between equal and similar.
Yes, ma'am.
Okay, because you already have math, so I'm not repeating because this is there in your syllabus. Now, whenever two triangles are similar, there everything becomes equal. Means corresponding things become equal. Means if AB is here and I take this AB, and if I take this AC and this A dash C, the ratios will be the same. Okay, because they're similar.
Yes, ma'am.
They're similar, so their ratio and their ratio will be the same. So we can say whenever you have two triangles written, the way you write them, A, B, C, so you have to take A dash, B dash, C. Now see, AB by A dash B or A dash B by AB is equal to whichever you have chosen first, CB dash by CB or CB by CB dash, depending on what you have chosen. So I can say A dash, B dash by AB is equal to CB dash by BC. A dash, B dash by AB is equal to CB dash by CB. Or in fact, you can say this also CA by CA dash. Got it?
Yes, ma'am.
Okay. Now, if I talk about CB dash, just this smaller part, this is a part of this bigger C and P. If from this bigger C, P, if I just subtract this B dash P, I'll get the smaller length, CB dash
CP. Yes, ma'am.
P. This is the bigger one.
Mm.
From here, if I subtract this will be left.
Yes, ma'am.
So from C, I can say CB dash. If I want to write down what's the value of the CB dash, I can say it is CP minus B dash P.
Yes, ma'am.
Okay. Similarly, if I talk about this BC side, means I have to get this, if I have to calculate this. Now you tell me how can we find out this one, BC.
BP minus CP.
Very good. BP minus CP. Now, what is the usage of all of these things? See, let us just mark what are all these things now. Look, now pay attention here, Vasmi. This is B. Can you tell me what BP is?
Ma'am, what BP is?
BP, yes. It's the length.
Uh,
Which length?
it's V.
Match it from
Image,
these.
image distance. V.
Is AB or image?
Yes, ma'am.
AB is
No,
the
not
image.
AP. I thought A dash and V dash. AB is my object, so it's
So
U, not V.
it is U, yes. Okay, now as we discussed, as per our sign convention, anything in front of the mirror is negative. So I've taken
Yes,
minus 2 as the object distance, which is negative. Fine.
yes, ma'am.
Okay, then can you tell me what is B dash P?
That's U. No, it's V. It's V.
Yield, image distance. Okay. So this B dash P, this is basically the image distance. B. Okay, and since this is also in front of the mirror, it will also be negative. Okay, U, V.
Okay, ma'am.
All right. What is CP?
CP is radius. R.
Radius of curvature. Okay. This complete is the radius of curvature. And what is FP?
FP is the focal length.
FP is the focal length. Correct. Okay, just this part, half of the radius of curvature. And see, everything is lying in front of the mirror, right? Everything is lying
Yes,
in
ma'am.
front of the mirror. So I'll say all are negative in this case as per the sign convention. So what was our CP? CP is minus V. See, it's written here. CP is minus R, B dash P is minus V, BP is minus U. So I'll put the values here. CP is minus R minus B dash P is V. So minus of V. See, minus sign from the formula and these minus sign from the sign convention. Got it?
Okay, ma'am. Yes, ma'am.
Divided by BP was U, so minus U minus. CP is again minus R. So we can say minus R plus V by plus R minus U plus R. Minus U plus R. Okay. We can say this is the equation formed.
Yes, ma'am.
We can say the ratio is equal to this. So if you put the values, you will get this. Now see, we need one more equation. Where will you equate this to? You simplified the equation. Now where will we put the values? Correct. We have to put the values as well. So
Yes,
what
ma'am.
we'll take two more triangles similar. Now from the pole we are going to take. If you look at these two triangles, this one ABP and A dash B dash P. This one.
Yes, ma'am.
BP and A dash B dash P. So here, if you see, they have the common side. An angle of incidence is equal to angle of reflection. Again, the triangles are similar, right?
Yes, ma'am.
So I can say A dash B dash P is similar to delta AB P. Now see here, A dash B dash by AB is equal to B dash P by VP. From here, A dash B dash by AB is equal to B dash
Mm,
P by BP. Yeah. What
Yes,
is B
ma'am.
dash P? It is minus V. BP was minus U. So we get V by
Mm,
U. Let's equate this. Now you have at least what is the value of A dash B dash by AB from here and A dash B dash
Yes.
from here. So we can equate. We can say V by U is equal to this is minus R plus V minus R by R minus U. V minus R minus U. So if we take the cross multiplication over here, look, minus from here, this will be UV minus UR. If I cross multiply this UV, so UV minus UR minus UR. Then I cross multiply this minus U into V minus UV and VR. Got it?
Yes, ma'am.
Now, see, this is the equation. Let me write the terms properly. UV minus UR is or let me do one thing. Let me shift the terms. Let me write the R terms together and UV terms together. So I can say UV plus UV is equal to, from here when it goes on the opposite side, VR minus VR plus UR. That's what we'll get. See, when UV comes here, it will be UV plus UV. And when this minus UR goes on the opposite side, it will be plus UR.
Yes, ma'am.
So that makes this 2UV is equal to VR plus UR. Now we'll divide this by UVR. Okay. Divide
Okay.
by UVR. So see, your equation is 2UV is equal to VR plus U. And now we are going to divide it by UVR, by UVR, by UVR. See what we will get. UV gets cancelled from here. VR will be cancelled. UR will be cancelled. What do we get? We get 1 by U plus 1 by V is equal to 2 by R. This R by 2
Yes. R/2 is focal length.
focal length. So 2 by R will be
1 by F.
1 by F. Okay, so what do we have now? 1 by F is equal to 1 by U plus 1 by V. This is the formula which is known as the mirror formula. We will see a similar formula which is known as the lens formula. Then lens. This is the mirror formula. Okay. So here what all things we have? This is the focal length. This is the distance. This is the image distance. Okay, and remember one more thing, you have to use sign conventions here. In this formula, you have to use the sign conventions and put. If I get object as 5
Ma'am.
centimeter, I'll use minus 5 here, okay? Use sign
Okay, ma'am.
conventions in the mirror form. Tell me, is this derivation clear to you?
Yes, ma'am.
All right. So you copy, just text me a done. And while you're writing, I'll just pray, okay, and come. It's
Okay, ma'am.
after time over here, and I'll be having consecutive classes, so that's why. Okay.
Okay, ma'am.
Just keep on texting done. Even if you have to wait, just wait. I'll scroll it. Okay.
Okay, ma'am.
You done?
Yes, ma'am.
Okay. So this is the formula. One more thing, you have the concept of linear magnification. Now, linear magnification is basically the ratio of two quantities, the height of the image by height of object. What is meant by this? See, if I have the mirror, let's say we have the mirror, and somewhere here I have the object. And let's say here I have the image. This is my object and this is my image. Now, linear magnification is what is the change? What's the ratio of their height? Like how has the height changed? Has the height increased or has the height of the image decreased? So that is given through a quantity known as linear magnification. And using the whole concept of linear magnification, you will be able to tell many things. You'll be able to tell the size of the image, whether it's diminished, the nature of the image, the things that we write. Many things can be solved using this. Remember, it's the ratio of height of the image, height of the image to the height of the object, height of the object. Okay, so from the same derivation, where we had APB similar to A dash P B dash. A dash B dash by AB was equal to B dash P by BP. Remember, here we discussed
Yes,
this. This
ma'am.
is minus V by minus U. See, A dash B dash was what? From the figure. This equation I'm referring to, minus V by U. Now, from the figure, what was AB? It was the height of the object. A dash B dash was the height of the image. Yeah? And see,
Yes,
this is
ma'am.
above the principal axis. So height of the object will be positive. While this is
Hmm.
below the principal axis. So height of image will be negative. So we'll just use that
Negative.
part. So A dash B dash is minus HI, AB is plus H naught. Why minus? Because this is below the principal axis.
Okay,
And
ma'am.
this is above the principal axis, but this one is the height of the image, this is height of object. This we have already discussed. This is the image distance, this is the object distance. So basically, magnification is the ratio of the height of the image to the height of the object, so that you can compare. Okay, this is known as linear magnification. When you compare the height, see, magnification can be of two types, linear, and one is transverse magnification. Transverse magnification means, see, instead of comparing their height, let's say this is a mirror. Now transversely, you're going to measure its length. Let's say this is the object which is put. This is the object, okay? And this is the image that
Ma'am.
you want to be. Because if the object is like this, image will also be like this. See, you are not
Hmm.
calculating its height. You will calculate it transversely through the transverse section. So this is what is known as transverse magnification. Got it? This is the ratio.
Yes,
Like
ma'am.
this one. Okay, this to this one. And this is the height of image to the height of the object, denoted by the letter small m. And yes, these are two more formulas which you should know. If you put the magnification formula in the mirror formula, means if you have 1 by f is equal to 1 by u plus 1 by v. Right, so from here you put the value minus u by v is equal to m. Using this, if you put it in the formula, you can get two formula, which derivation does not come. So that's why I've written the formula directly. So if magnification is given to you, f is given to you, object distance is given to you, but image distance is not given. Okay,
Hmm.
in that case, you can use this and calculate the value of V, or you can calculate M.
Okay, ma'am.
Image distance is not given, focal length and only object distance are given. Calculate magnification using these two only, F by F minus U. Or suppose you have focal length given, image distance is given, object distance is not given, then how will you calculate the magnification? Use this F minus V by F. So before this, just one more thing. You can finally say, we can compare minus hi by h naught is equal to minus v by minus u. If I put
Yes,
it here,
ma'am.
So this will be cancelled. I can finally say hi by h naught, which is the magnification, is equal to minus v by u. This minus from here. So this is the formula that we'll be using. This is your main formula. Okay. Now I told you about the
ma'am.
interpret using magnification. How will you calculate the rest? How will you interpret it? So interpretation you have to remember because many questions come from this. See, first you will see whether the magnification's magnitude. Now when I say magnitude, you have to consider its magnitude, that is the without any signs, no plus, no minus. Okay, just see the number and check, is it greater than 1? Okay, just check. Like if I give you a number 3, you know it is greater than 1. So that tells the
Yes, ma'am.
image formed is magnified. Because see, it means the numerator was big. That's why you are getting a value more than 1. And our numerator was height of image. It means height of image is more. That is, it is magnified. Okay.
Okay, ma'am.
Now, if you see the magnitude is less than 1, let's say 0.5, you have calculated and it is coming out to be 0.5. Now this is less than 1. It means the numerator was lesser, denominator was more. Height of object was more, image was less. So image is diminished. And if the ratio is exactly the same, means both have cancelled each other. It means both the values must have been the same. So image is of the same size, same height. Image and object. Image is exactly of the same height as that of object. Neither magnified nor diminished. So you check the magnitude. I'm again saying magnitude. If I give you, just tell me one thing. I am giving you one magnification as, let's say -3, and I'm giving you the next magnification as -1. Tell me which is magnified, which is diminished.
Both are diminished, but M1 is more diminished than M2
Why?
because it's less than 1, right?
And what did I tell you? Magnitude. You don't have to see. Do we
So,
take them? Then
no, then both are magnified.
both are magnified.
Yeah, if you're taking the,
Can you explain?
if you're taking the without the sign, then both will be magnified, right?
Why? Reason.
Because it's more than 1.
So is this also more than 1?
Or no, that one is the same size.
So this is magnified. This is of the same size. Okay. If I
Yes,
say
ma'am.
m is equal to 0.38. So this is directly less than 1. Okay. So this is diminished. You see the magnitude when -3 is given. No, -3 often tricks us because 3, we know it's greater than 1, but -3 is obviously less than 1. But we don't see the signs. Okay. We ignore the sign. Just take the magnitude and
Ma'am.
then use. Okay. Now, so how,
Um,
what are the functions of, yeah, say
If if you
what?
take the magnitude wherever there is minus, then there won't be any diminished image, right?
Why? I just gave you an example. If it is minus, let's say 0.24. Now,
Mm.
it will be,
It's
it is less than
yeah,
1.
like yes, ma'am. Yes, ma'am.
Yeah. So you just have to check the magnitude. Now, what's the use of the sign for them? If this is what the magnitude is, then what's the sign? Sign is basically to tell whether image is virtual or erect or real and inverted. Because, okay, magnified and all we have got. If your magnification was positive, like plus 0.3, which I gave, so image is virtual and erect. If magnification is negative, it means it is real and inverted. Like if I say magnification is -3, 3 is the magnitude that tells me that image is magnified, and minus sign tells me it is real and inverted. So see, by just having the magnification, you are able to see so many things. Got it? So these questions
Yes,
come,
ma'am.
long lengthy questions will come, where you'll eventually have to calculate the magnification and answer these questions: nature of image, size of image, and this formula for the position of image. Okay.
Okay, ma'am.
Any doubts still here?
No, ma'am.
All right, then you write down this one as well.
Okay, ma'am. Ma'am, can you scroll down? Can you scroll down? Can you scroll down? Can you scroll down? I'm done.
See, this says that an object is placed at 9 centimeter in front of a concave mirror. Okay. Radius of curvature is given as 15. You have to find position, nature and magnification of image in each case. Each case means two cases are given. This is 10 centimeter, this is 5 centimeters. Okay.
Ma'am.
So tell me in the first part, what is the value of the u? We are solving the first part.
10 centimeter.
Is that correct?
And 10, an object split 10 centimeter. Yes, ma'am.
Sign convention?
No, minus 10.
Minus 10.
Yeah.
Okay. Radius of the curvature is given as 15 centimeters.
16.
What is the focal
This
length?
was mine. Focal length is 15 by 2.
Yes, 15 by 2, that is 7.5 centimeter. So how should the focal length be written? Positive or negative?
Both are negative.
Hmm?
But it is negative.
Why?
Because focal length is also in the left, right? Yeah, it is negative.
For a concave or a convex?
For concave.
It is negative. Then for a convex?
Yeah. For a convex, it is positive. Right?
You're right.
No?
Yes, you're right. See, remember like this. Wherever the concavity is present, wherever the surface is available for reflection, there only you will have the focus. So concave will have the focus in front of the mirror. So negative. Concave is like this. The inner part has been painted. Where your focus is present, that part is painted. Are you getting
Okay,
it?
ma'am.
That's why
Yes,
this
ma'am.
acts behind the mirror. So remember that
Mm.
property. Okay. So yes, minus 7.5. Now it says, now this much data is enough. See, if I take 1 by f is equal to 1 by v plus 1 by u. That makes this 1 by 7.5 is equal to 1 by v plus 1 by minus 10. So this is 1 by 7.5 equal to 1 by v minus 1 by 10. So this goes on the opposite side. This will be 1 by v is equal to, okay, f is also negative, no? So this will be 1 by 10 minus 1 by 7.5. Is that what we'll get?
Yes, ma'am.
So this will be 1 by v is equal to, this is 7.5 minus 10 by 75. 7.5 minus 10 is 2.5. So 2.5 by 75, which is 1 by 30. Sorry, minus 2.5. So minus 1 by 30. So v will be minus 30 centimeter. Now, this means the image distance is 30 centimeter behind the mirror or in front of the mirror?
Image is behind the
Why?
mirror. It is, see, this is concave. So image is in front of the mirror. No, it's in front of the mirror. Minus.
Don't have to see that. Don't apply so much of the concept of ray diagrams here. Look at the value, minus 30. Why will it be minus? Minus means in front of the
No,
mirror. Okay,
front of the
directly see
mirror.
this. If this
Okay,
was
ma'am.
plus, Then in concave, you get one case where you get positive image also behind the mirror. Then how do you know which case is this? You getting it?
Yeah.
Okay, so
Yes,
just see
ma'am.
the negative and positive in front of the mirror. Now, magnification we need. So magnification is minus V by U, minus of minus 30 by object distance is minus 10. That makes it minus 3. Now, if magnification is minus 3, tell me about the size of the image.
Um, it is magnified
Magnified,
because
because
it's the
magnitude is greater than 1. Therefore, image is magnified. Correct. What about the nature of the image?
it is real and inverted.
Yes, since it is negative, therefore it is real and inverted. And finally, the position 30 centimeter in front of the mirror.
Hmm.
This is a question from your NCRT, front of the mirror. Now it's clear how to write the complete answer and locate your final image.
Yes, ma'am.
Write it. This is the first part, 10 centimeter, 5 centimeter one you will do by yourself. So see position, nature, magnitude. Write it.
Okay. Ma'am, can you scroll down? Ma'am, can you scroll down? Ma'am.
Okay, so you've understood the question properly?
Yes, ma'am.
Okay, so few more questions we'll discuss in the next class. First, you attempt the assignment. Okay, I'll give you an assignment
Okay,
first. Let me start with plane mirrors. Now, see, what is exactly a mirror? A plain mirror is a very common thing for you. Okay, because plain mirror is something that you see every day. I hope mirrors you are
yes,
familiar
ma'am.
with completely. Now, see, you'll be easily able to relate it because mirror is something that is of our daily use. Every day we see ourselves into the mirror. So, mirror is basically a smooth, highly polished, reflecting surface. So, you also represent it through a straight line because it is plain, no curves are there. And one side is again polished. So, one side is available for reflection while the other side is available. Basically, it's silvered, available for polishing, silvered or polished. Okay, so what's a plane mirror? A highly polished plane surface. This is the difference. Your concave and convex mirrors, they were the curved mirrors. Okay, so this is all called a plane mirror. Different properties of image formed by a plane mirror. These are some properties of the image formed by a plane mirror. See, whatever when you see yourself, do you see yourself enlarged or you see yourself very small, diminished? You see yourself exactly of the same size which you are. So size of image and size of object. Anything, even if I take a pen and I see, it will appear exactly the same. So size of image and size of object will be the same, exactly of the same size. Means height of image is equal to height of object. True or not?
Yes, ma'am.
Now, magnification is unity. When the size of image and size of object are equal to another, the magnification is unity, means m is equal to 1, which is the third case. Remember, magnification 1, size is exactly the same size. Okay. Now, distance of image is equal
Ma'am.
to distance of object. If I have a mirror, let's say this is a mirror and here my object is put. So here only I will see my image. This is the object, this is the image. So U is equal to V. Clear?
Yes, ma'am.
Okay. A plane mirror may form a virtual as well as a real image. Real image or a virtual image, both are possible for a plane mirror. Because why a real image? Of course, this is formed behind the mirror. Image is formed. Then why do we say virtual or real image? Real object is the real image will be rare. But what if multiple mirrors are connected? Then there can be a virtual object which can create a virtual image. So that's why plane mirror may form a virtual as well as a real image. A man may see his full image in a mirror of half height of man. Means see, a man may see his full image in a mirror of half height. Means if the person is standing in front of the mirror, the height that is appearing, this is a numerical, in that it will be clear. Basically, the half of the height is visible. See, when you're standing in front of the mirror, so you are able to see half of your height. This is what it is saying. A man may see his full image in a mirror of half height of a man. Okay, this we'll see it through the numericals. That time it will be clear. Now, what kind of numericals come? It says when two plane mirrors are held, or do one thing. This will be a little difficult. You write down till the properties. Okay, till here.
Okay, ma'am. Ma'am, I'm done.
Okay. So, what all things have you understood from this plane mirror properties? Just tell me quickly.
Ma'am, the size of the image and the size of the objects and the size of the image are the same.
Hmm?
And so magnification is 1 since the size is equal. And the distance of the image and the distance of the image from the mirror and the distance of the object to the mirror is equal. And plane mirrors can form both real and virtual images.
Okay. Last one.
Um, a man can see. Wait, no, Mama, actually, I didn't get the last one.
See, last point basically means see, let's say I have a mirror of a person is there whose height is, let's say, 180 centimeter. This is the height of
Okay,
the
ma'am.
man. Okay, so he will be able to see
Mm,
his exact full image in a mirror of 90 centimeter. Means half of his height.
mm.
Okay,
Okay, ma'am.
all right. See, just look at these two. When two plane mirrors are held at an angle, you must have seen in malls where you have the trial room, three mirrors are there, two mirrors are there. So there are infinity mirrors also. Means you are able to see image inside image like this goes. Have you ever seen this?
Yes, yes, ma'am.
So, what is the number of images? This can be asked. So, when two plane mirrors are held at an angle theta, number of images of an object placed between them is given by two methods. 360 divided by theta minus n, where 360 by theta is an integer. This will be commonly used. Just in case, this means formula is this 360 divided by the angle by which the mirror is inclined minus 1. That gives the number of images. Okay. This n will give the number of images. 5 images will be formed, 8 images will be formed, 1,000 images will be formed, and on. But if you see 360 by theta is not a or not an integer, then it will just be 360 by theta, which is usually be given the first part. Okay. And this application is used in kaleidoscopes. This is how the kaleidoscopes look like. This I'll tell in the next class tomorrow. And numerical also we'll do.
Um,
Just write down this formula, this part from